wood stoves and fireplaces, etc., as well as gas, but mostly wood. Other residential sources here. Mobile dust. This is dust from road dust. Vehicles picking up road dust. Exhaust, this part here. These are locomotive emissions right here. Open burning. And this is the background contribution right here. Will be here anyway, regardless of human development. If we look at this in table form, we can see the percentages for 2005 are right here. So permitted users, these are all the industrial sector, about 21%. Locomotives, about 15%. Background, about 14%. On-road dust, about 14%. Restaurants, about 12%. We think restaurants are too high. This is a change from the first iteration to the current iteration of the modeling study. We think that the restaurant emissions are too high. The inventory has not been looked at in detail. Dennis Fudge has been looking at it, and there are too many restaurants of the wrong type in the emission inventory. And there's some issues also with the characteristics of the restaurant emissions, the temperature of the emission source. And you have a hot plume coming up, it's buoyant and it rises further and it gets dispersed better in the model. If you have a cool plume coming up, it doesn't rise as high, disperses less, and so you have higher contributions to the ambient levels, for example. So Dennis is investigating that right now. And we hope to do a follow-on study to look at that as well. So that's restaurants, residential heating, about 9%. This is mainly wood stoves and things like that. On-road mobile, so this is vehicle emissions and diesel vehicle emissions, about 6%. Open burning, 3%, etc. So this is what the model predicts by sort of major source category. Now, I'm not going to show this here, but we can break down each of these category emissions as a percentage or as an absolute value in micrograms per cubic meter. We can break this down into individual sources, individual emitting units. So we can break it down as far as we want to go. If we look at what is impacting the plasma monitoring site in the model, SEU means source emitting units, so these are particular emitters that we have in the model. We can see that the plaza site is affected a lot by dust for PM2.5, more so, even more so for PM10. This is dust from Highway 16, the whole highway is kind of one source here. This is the impact from restaurants. The impact from 15th Avenue, from Victoria first. The impact of the Miller Addition, space heating, wood burning stoves, etc. The impact from the BCR site, from dust. The impact of the railway line to Quesnel, over here. The impact of the South Yard railway line. The impact of Highway 97. The impact of the railway to Jasper. And whole area dust in general. So we can see that, a major, if we rank it by emitting unit. Now here, it's a little bit hard to compare emitting units because we've got a whole, 5 kilometers of roadway as one emitting unit. So you can't really directly compare that with, a stack or a fireplace or whatever. So they're apples and oranges we're comparing here. But these are the emitting units in the model and their contribution to plaza. If we focus in on heavy industry, and these are sort of the major emitters, or what are thought to be the major emitters, we have the refinery here. So these are the percent contribution as a percentage of all the permitted users. So if we took all those 33 permitted users and treated them as 100%, these are the contributions of the individual major facilities. So here's the Husky Refinery is very small for particulate matter. This is Northwood Pulp. This is PG Pulp. This is Intercon Pulp. This is the impact of the BC Rail site, the Gladstone site, the Plaza 400, etc. So you can see that, summing them all up, these major heavy industries are accounting for 30 or 40 or 50% of the industrial emissions. Then if we relate that back to the total contribution in ambient levels, they're quite small. So this is 0 to 100%. And these are the contributions of each of these 4 industrial locations to these monitoring locations as a total percent of the total ambient levels. So they're a fairly small contribution. 20% on average is the industrial sector, the total industrial sector. Of that, perhaps half is coming from these four facilities at these locations. Well, as was mentioned, there have been other studies that have been done. And so there has been a source apportionment study that was done. And I don't want to get into the details of that here too much, but I wanted to show you a little bit of a comparison between the dispersion model results and the source apportionment results. So first of all, this side of the table are the results from the source apportionment study, the STI study. And so the STI study used two methods, chemical mass balance and positive matrix factorization, PMF. And it broke down broke down the types of sources into these broad categories: a pulp mill source, a burning source, a carbon source. And the carbon source includes vehicles, both diesel and gas in this case, as well as other forms of organic carbon. A soil source, which would be a dust type of a source, and other. So this is what the receptor modeling studies did. And so, based on these two methods, they found that at Plaza, for the year 2005, the pulp mill source accounted to roughly a quarter of the particulate matter there. A burning source, this burning source is primarily low temperature burning, so like wood stoves, etc. It's marked by levoglucosan, which is a sugar which is destroyed by high temperature combustion. So estimation between a quarter and 20% roughly of contribution to the Plaza particulate matter level. Vehicles, this includes cars, trucks, and locomotives, because they can't distinguish them, okay, because the emissions are similar. So roughly a quarter. Soil, this is all the dust sources. Quite a low contribution, only 5% and 10% for the two different methods. And there were a considerable amount of sources which couldn't be, which are other sources or were not modeled properly, so between 20 and 25%. So if we compare that, then what I did was I took the dispersion model results and grouped them into the STI categories. So I said, well, I'll put all the permitted category, even though permitted also includes other sources besides pulp mill. I put all the permitted emissions, and there's 21% in the dispersion modeling study. If we take the burning sources and group them with restaurants, residential heating, open burning, and residential other, it's 25%, so that's comparable. If we take the carbon types of emissions, so we include locomotives, on-road mobile, which are vehicles, and commercial heating, which is mostly natural gas, we get 22%, and that's quite comparable with what the receptor modeling study found. The big discrepancies come with the dust type of sources. And so the dispersion modeling study estimates about 30% is due to dust, on-road dust, commercial dust, and background level. The background level is also a type of a dust source. So about 30%, and the receptor modeling study only found 10 and 5%. However, there were a significant amount of other here as well. And the other probably isn't all dust, but some of it could be dust. So that's a comparison between the types of studies that were done. Okay, so in summary, I'm winding down here. This study found that the PM10 especially, and to a lesser extent PM2.5, heavily influenced by dust emission sources, especially on-road vehicles. For downtown, the concentrations attributed to restaurants seem too high, and the work that Dennis has done has identified that the emissions are too high, the emission inventory is too large, and there are some issues with the model parameters as well. So that's being reevaluated currently. The permitted user emissions don't really dominate the predicted PM10 and PM2.5 levels, except right near the facilities. So on an airshed-wide basis, they aren't the major contributor. They're significant, but not the major contributor. There are many sources. We think the model is under-predicting, however, the ambient levels of Plaza when the winds are from the east, so there's probably a bias in there. We also did not model fugitive dust emissions from industrial facilities. That was a category which we didn't model. So the lots, the yards, etc., were not modeled as particulate matter sources. So we didn't include those. It should be done. And we also don't have a very good handle on condensable particulate matter from industrial sources, so there could be an issue with the sources from the industrial sector as well. So what does it all mean? Well, okay, so results we have are the best information to date to guide air quality management decision making. Nothing is perfect. There's no silver bullet here. We have to go with the best information we've got. The studies that have been done are state-of-the-art. We're using the best models. The speciation studies were well done. The modeling study is solid. There are some issues, but they're being resolved, and they're not major. So the current results with interpretations and adjustments can be a basis for ranking sources for reductions. We think there are some issues with restaurant emissions, for example, and other area sources like dust, etc. And also secondary sources which form in the atmosphere may not be done quite right, but these are probably minor problems. So what do we need to do? We need to clarify the restaurant emissions. Dennis is working on this right now. We also have an application in for grant funding to support this work through the BC Clear program. We'd also like to make the model results more available to those of you in PG Air and others, and the public as well, who are interested in seeing what the impact of sources are. And we'd like to develop a tool where we can play with the sources, adjust the sources up and down and see what their impact would be. And so we also have a funding application in to develop a tool to make these model results. There are nearly half a terabyte, about 500 gigabytes of data, model output data, sitting on a disk that can be utilized to do these what-if scenarios, to see what would happen if we turned this source down, what would its impact be. But it's difficult to access that data and understand it unless you're a modeler. So we'd like to try and simplify that link and provide a tool for managers to be able to look at this data and utilize it. Okay, that's my presentation. I'm happy to take any questions you might have. If there